one of the things that I found that was, let's start this up again. Yeah, so discrete event simulations, how they sit in the world of maths, part 2. I've got a point now that I've done that. Anyway, I'll get back to the slides. Maybe it'll really go to me. This book that I was reading, yes, that's what I was going to say. It describes how the maths of discrete event simulation relate to the world of continuous simulation and of calculus. Well, calculus, you're about understanding of the relationships of stuff based on the data, based on changes in data, the rate of the change of data, so, dx, dy, that's how it works. So you have to adjust the increment for the particular study of the data that you're interested in. That's one of the key manuals or knowledge things of a machine learner expert, data scientist, that they need to know that if you get your increment wrong, you find the answer too slowly, you make the increment too big, you never find the answer because it's like some sort of crazy pendulum that gathers momentum rather than getting to where it needs to be. Continuous simulation, again, kind of increments again, but not events. This time these are, they are events. No, they're regular beats of a time system, units of time, that you're then able to sort of stop, frame, animate, as it were, simulation. You can fast forward stuff, but this is what people are already using with robots, with Gazebo, which is a very popular thing. Most of the DARPA robots, where you've seen the challenge that they've put on, it's something like 70% of them use Gazebo, this continuous simulation tool. Actually, if you're making notes, all of these slides are on my blog, so you can revisit it. So, sorry. No, that's fine. You carry on. But it's all out there as well. Right. So Gazebo, has a physics engine, so it allows you to analyse gravity. So that's an aspect of an AGI where you're going to want to be able to think about how hard do I turn the handle, kick the thing, whatever, in order to get what I want. So the discrete event simulation with events, the calculus and the continuous simulation are actually special cases, subsets of the bigger picture where you've got a model and events being derived, from that model situation, which haven't got a fixed time period as to when, they could occur rapidly or repeatedly or occasionally, or perhaps, not at all. They may be sort of provisional events, as it were. You're not sure whether or not that outcome is going to happen at all. You could use this technology for doing all of the maths associated. It's a superset of these other mathematical ideas.
So, what's a superset?
Superset.
Yeah.
It's in effect, if you thought of human is the superset of adult and child. So adults is a subset of human, because not all humans are adults. So it's like, the experience or the class of adult is completely described by the class of human. The human is the bigger class. The human has more properties to it than adult. Well, similarly, calculus, continuous simulation, the mathematics, the tools and the opportunities, as it were, are a subset of the world that is discrete event simulation. Because you can do, you could graphically do calculus, as it were, with a discrete event simulation tool. It wouldn't be an appropriate way of doing it because there are better tools for it, but conceptually, it has it's a bigger toolbox. Yeah. Anyway, yeah. So this actually then. Oh, sorry. Yeah, I need to use the mouse rather than. Actually, it's 8:15, and I'm talking about all this. Is people okay to me to carry on? We've got this place, but I'm still keen. You're not looking bemused rather than.
No, it's just keeping your arms up, is it?
Sorry?
So it's just taking the videos.
Your arms are getting tired.
Yeah.
Yeah. Sorry about that. Maybe could you prop it up, maybe?
I've tried. There's not enough room to get you both in.
Yeah.
And I need to be over there, or.
Yeah. Yeah.
Oh, it's all right. Continue. It's all right.
Okay. All right. Well, you're getting a workout. Unfortunately. Yeah, you didn't expect that to happen. Right. So I've been talking about discrete event simulation in the manufacturing world, where the technology is it isn't very open, as it were. The XML that Lana have that does the saving from that kind of stuff is all part of their own tool, and there are other people who have similar tools, perhaps not as good. Lana is certainly the high end of these kind of tools. They're very powerful, very functional tools. But there is more of an open standard in the business world, the business process modeling, BPM, as it's known. So this is shouldn't touch the touchpad. Yeah. So in effect, this is hang on. Paul's talking, and we'll listen to an enthusiastic voice instead. This is a video that only takes 4.5 minutes.
HEMSEYE provides powerful simulation capabilities that enable organizations to make better decisions by visualizing the impact of proposed ideas and changes prior to implementation in a real-world setting. HEMSEYE simulation is robust and easy to use. To better illustrate the advantages of analyzing your business operations using simulation in HEMSEYE, let us consider a practical example. Michael is a process analyst in a bank. He has identified some problems in the call center that manages varied queries, credit and debit card blockings, and services activation. Currently, calls take a long time to be processed. Customers are dissatisfied, and some employees are complaining of work overload. Michael wants to analyze suggestions for improvement without disrupting the service. Moreover, the bank will not invest money and time in a proposed solution where the impact is uncertain or unknown. Michael decides to simulate the process using HEMSEYE to evaluate the ideas in a risk-free environment. To do so, he starts with the process model. He clicks on Simulation View to enter the simulation environment. Although Michael is not...
Just got to pause that there. So obviously, the blobs look different and they're a lot simpler. You've got a lot fewer blobs because there's a standard of what the blob opportunity, the drag and drop opportunity is much more limited here. The fact that we've got queries agent and call center agent, these actually effectively, are separate people or separate rooms, perhaps separate activities. So these are independent processes, as it were, that are being modelled in what they call swim lanes. Yeah, so this is a pool, the pool being an entire process, but the swim lanes being a thread of control, as it were. So where information is being passed from one room to another, as it were. Now, when we're thinking about conversational agents or understanding a conversation, the fact that you are able to create a simulation where you're looking at an outcome or a meaning for a particular person or a particular person's mindset, their view of the world, you can therefore model different things in different lanes, as it were, and link them together, and then think, okay, well, I think what their position is about here, my understanding, and this is what I've created in order to persuade them to behave differently, or in order to alter the outcome in that different lane, as it were. And we're seeing here, lines. Well, with this standard, it can be flows of data, or it can be events. There's a whole raft of complex, different stuff. That gives it a complete capacity to describe the business world where all this tech is being used. So, to me, in looking at this, I thought, well, that's an opportunity, because it's a position to start from. I mean, if instead of these blobs we had words and physical things, but we had these swim lanes, you could do cool stuff, I think. Anyway, but nobody's paying me.
Not a simulation expert, it poses no problem. Through the 4 intuitive levels, you will progressively present the necessary information to mimic real-life system behaviors.
Yeah.
In the first level, process validation, Michael checks that the process flow works as expected. Make sure it calls are processed and flow routes followed according to probable scenarios. This step will prevent modeling errors showing up in the results of the success.
Oh, do it again. Actually, as you can see,
This AGI provides
each of those different simulation elements have in effect got their own.
Once validated, Michael continues the second level, time analysis.
It's got its own sort of wizard pop-up interface. And so contained within the simulation element, the dependencies and the stuff, that particular object context relates to, the system has a description in XML of the stuff that needs to be plugged into it or could come out of it, as it were. So, it's a good way of describing the real world, I think. Anyway.
He defines the frequency with which calls arrive at the process and the durations of activities.
So a bit of statistics there about how
The time analysis level shows the ideal end-to-end processing time under the current conditions.
Yeah.
Now that Michael knows how the process should perform, he can introduce more.
What they don't describe here is that in these models you end up with describing what you call an optimization function. So you need a mechanism of deciding what your optimization function is. So this is describing very complicated stuff, and an AGI would need to be very clever and experienced to be able to generate something like this. But if you started off with the small stuff, how with a growing experience, how far could you go in developing this kind of understanding? If you were to bootstrap knowledge of language.
Existing model, taking into account the resources needed to perform tasks. In the third level, resource analysis, Michael defines the resources available and the requirements for each task.
Yeah. So
The simulation shows the resources utilizations and highlights possible delays from calendars defining the available. What if
Okay, so this is the kind
decides
of
to evaluate the impact?
the punchline in this is that, you know, it wasn't a very complicated question. It was fairly obvious that they needed to figure out how to optimise their shift pattern, and they probably didn't need a simulation tool in order to answer that, because, you know, you go and ask the office supervisor, what are the problems? Well, we're run off our feet about 11 o'clock. But you know, there are some problems where this is actually necessary.
Resource distribution in the tasks. He intended.
I mean, in knocking this or saying that this is a simplified case, one of the things that these tools do is give you the opportunity to dynamically create data entry forms and a database behind it as a workflow system, so you can define a company process and allow you to see how all this can be used.
To augment the availability of the overutilized resources.
Anyway.
To do this, Michael creates a scenario, the same configuration as the original one. He makes the necessary changes in the resources configuration.
Right. Okay. So, won't talk any more about that. So there are XML standards. It's very widely used. It's used there's business process modeling notation, and the extension to make it simulated, BBSim, which are defined by the Object Management Group, which are a big international organisation. They define UML, which I mentioned earlier. It's a good, common language to start from. There are, so you could start here, or there are other standards like SysML, which is a different standard, which is less well developed in the simulation world, but it's very popular in engineering. So there's actually a conference in Stanford between SysML and AI. So there are people next year thinking about what the opportunities are in this field. Whether they've thought about it as much as I have, I don't know. Anyway, but BPM and BPSim are more highly developed than SysML. So actually what's going on here, as I kind of hinted, there's this core simulation engine which has got a startup model of that's describing business process modeling notation, those particular shaped blobs, those drag and drop elements, tools that are in the toolbox that allow you to produce these. And that's actually described in XML. It's not hard-coded stuff necessarily. Oh, actually, no, some of it is hard-coded stuff. Anyway, and then there's a new user interface on the front of this. When I worked at Lana, I was involved in writing the original XML schema for the core engine itself, and also in some of you might remember Popkin's System Architect tool. It was a computer-aided software engineering tool that was very big and popular. Anyway, we wrote I wrote the first specification for converting that process to, which is why I had knowledge in this area, expertise and experience. Popkin got bought by IBM, and they got part of the Rational Suite, which has been around for donkeys and has got various iterations. But the Rational Suite simulation bit was, and I think currently still is, provided by Lana's iSim. It's also used, well, as you see in the Visagi thing, Oracle uses it as well. It's used all over the place. Anyway, they're the go-to people for embedded simulation engines. So you need something like that, new startup model that's involving a robotic and a human world rather than this business world or the manufacturing world that we've been looking at. But, it's doable. Been involved in doing it in the BPMN world, and I think it could be done in the AI world. Well, So how are we going to do this? You're catching on so far with you can see where I'm heading for this. As I mentioned, you've got these manufacturing or alternatively a business BPMN, business process modeling notation. That's the Biagi tool that you load up in your simulation engine. And you've got a human user, tea drinking Englishman, it's, me, using a simulation tool, user interface, going into this simulation engine, producing simulation models, going off somewhere, to be applied in some useful manner. Well, you could plug it into a virtual world, these simulation models, and you could plug the virtual world into an AI, and you could have the AI feeding direct into your simulation engine, and you could have a human and AI robotic startup model. As it's all existing technology where you would be iterating what has been done before to actually end up with an AI that is able to act independently of a human, but it has knowledge of the virtual world, and so that, I believe, is what this thing could do. So when do we understand the semantic primes and the natural semantic meta language? From egg to tea drinking Englishman. Well, babies are self-aware at 6 months, interestingly. So what I mean by self-aware, you sit one in front of a mirror and you put what they call rouge, red, something like that. That's what we use in this experiment. They call it the rouge test. What the baby does is it wipes the rouge off its nose, because it knows that what it's looking at is it, rather than waving at the or looking behind the mirror. It's self-aware. It's able to understand its sense of self. But then it spends 12 months before it starts talking. 18 months before we start talking. So we need to understand what the skills are that would allow you to produce the ability to acquire language. Well, there's a theory of language acquisition device in that linguistic world. So they define the language acquisition device, but they haven't actually told us what's in it. I'm aware that this is sort of 8:30 now, and I wonder whether we ought to pause here, because this has taken quite a while. You can see that there's a lot more on my blog. I can tell you where this is actually, if you want to take a recording of it. It's important actually, because I've had some aggravation with my hosting company that it's important you get the URL right, because if you miss the HTTPS out, they've not managed to get it to redirect properly in WordPress at the moment. So, I'll post it onto the Meetup website. That's what it's about, where to find it, and you can message all of this. But give you a quick overview as to what's left. In summary, there's work on comparing humans and apes, and a realisation, as you would expect, that the reason we're different and clever is because of our ability to have a social perspective of what's going on. Big time. The fact that I know what you know, but you think I'm actually, my cognition means that I can decide to cheat you, kind of type things. Or corporately, we can choose to cooperate or have a community view and share a community view, and I recognise what the community view is, and so on. So it's those skills and that capacity to simulate or align myself with the consciousness of others that give humans the greater capacity compared to apes with the ability to use language. Well, what I've been talking about in terms of simulation, and this stuff that we've talked of, it is complex software, but all the tools are there, I believe, to start to model, start to build a system that is going to allow you to do this kind of stuff. Anyway, there's a lot more there. Then right at the very end, Yeah, we'll whiz through all this lot, I think, because it's Chomsky's language acquisition device, Tomacello, and his stuff about he's published a lot, well regarded chappie. How you put that into a computer with a design of self-awareness and different perspectives. What you were talking about earlier, the hive mind's eye, the HEMSEYE project. If you imagine a Wi-Fi enabled bee connected to a past hive of experience repository, bee arrives somewhere, don't know what to do about this new situation. Oh, hang on, the idea pops in my head because, as a corporate hive, we've had this experience before, and I can choose to do this. Well, an AI doesn't have the focus and the amount of data experience that a human child will have. The grant will run out and people go home and the AI isn't learning, but AIs can be Wi-Fi enabled and can be a swarm. So the rate of learning of the AI swarm, if they're using this cognitive repository of lookups of models of stuff about the world, simulation models, mini simulation models of this is how this works, cause and effect, understanding cause and effect, observing it, then it can rock, I suppose. Designed for the HEMSEYE server, Hive Mind's Eye server, the, as it were, Star Trek computer, as it were, that you talk to and it tells you stuff. You wouldn't need the World Wide Web anymore. You just chat to this thing and it tells you what the answer is. You say, tell me what is the London, I can't remember what they call it, some obscure, financial market. What's that? Explain that to me. It'll generate a presentation and tell me all about it, potentially. If it managed to get that far. Virtual world and simulation of concepts and how to relate that. Artificial consciousness. There's work about doing this in Memphis, LIDAR project, which was my original reason for getting into interesting stuff. Models of what consciousness is, and 3 different flavours of it there. Could be implemented in layered software. What to do next? Well, Siri type of thing. A whole bunch of activities which we could do next. In terms of looking at tasks, that would be needed to be got on with for, to do with robotic operating system, which is out there as a very popular thing, and getting all of this testbed type stuff working together. How well does it fit? Well, I think it fits really well with what DARPA are saying. If you've read the links from DARPA, talk about that some other time. There's a professor in Edinburgh who is expert in all these topics but doesn't know anything about software engineering. I think it's a very good fit with what he is after, is saying is needed, as far as I can see. How well is this stuff talked about? Well, Chomsky said that we needed a language acquisition device, that it was sort of like something that was inherent, that we are born with, but there hasn't been much explanation of what actually goes into it. The standard textbooks for computational linguistics doesn't mention semantic primes. The chap who wrote a recent book about modelling babies and robots, no mention there, although there's an entire chapter on language acquisition. First language acquisition, entire book on it, a Stanford professor, 3rd edition book, no mention of semantic primes. Jeff Lakoff, a student of Chomsky, got his own particular branch of linguistics called cognitive linguistics. He's come up with an idea that's kind of similar, but further a bit more detached than semantic primes, not so lower level. He doesn't mention semantic primes. Sussex University, big on natural language. UCL, again, big on language, big departments. There's a meetup group that comes out of UCL. Guy I met at Google, because you get invited to Google if you lead up one of these meetup groups in machine learning. It's cool. I've been twice. Meet all kinds of interesting people, including people from the Cabinet Office who want to see this presentation, which is why I've been recording it. Who knows what's going to happen? Exciting times. So, need to have some money, need to make some money, have some fun, not do any harm, damage, open source. Is anybody going to trust me with it being open source? That was there. A bit more about my background. I'll skip over that. You can read about, my past history and abilities and stuff. But I'm one of those weird dyslexic types who've got a very high ability to visualise stuff. So I can't spell. You probably may spot some typos. But anyway, apologies. It's not my skill. Things we could do next as a group. There's a list. Pause. Sorry, I've bashed your brain so much. Hopefully, it's been fun. But you can see that there's a hell of a lot to get your head around. I've been thinking about this far too much for far too long, and I've been needing to get it off my chest. So thank you.